All right, here is one of the example. First, we have defined a variable called num. The number is 4, right? How about we want to divide it by 2, right? We can have it. This one, we first define the first function, right? This is the first function. Let me show you the old way. The old way of defining a half function is the half 2, right? The second version of the half. Half 2 in here, right? This is the old way. We define a function, get the value, return a value, int. The int, what will happen is when we call this function, the number num will be copied to x. Right? It is copied to x. And in here we can divide x by 2, and then we can return half of the initial number, right? This is the return value. And so we can give it call it like this. This is the initial value number, this is a new number. We can put the half of it, and then let's see what will happen. We can compile and then run it, right? As we can see, the new number is 2, and the old number doesn't change, right? This is our old ways to write a function, like this way. Getting the parameter passing, number assigned to x. But how about our new ways, right? Half 2 and the half. What's the difference? The only difference is we put an and sign here, right? Here we don't have and sign. Here we have the and sign. So now x becomes a reference. So when you call this function half 2, let me change it to half. When you call the function half, it's calling this function, right? Because it's an and sign, x is a reference to number, which means x and the number are just two names. They are pointing to the same variable number. We're doing the same work, right? X divided by 2, return x. You can continue using this way, return it. And then let's see how it works. When you compile, you run it, right? Now it's different. New number. X expected is half of that because it's the return value. It's 2. The old number, initially is 4, now becomes 2, right? So that's the difference. The half is passing by value. You are copying the value. Half 2 is passing by value. Half is passing by reference. So that's the difference. You can change the values inside your main function. So in here. Any questions on the difference between half 2 and half? No, right? All right. So as you can see, if we use this way, right, it doesn't make sense, right? Because we already have the x divided by 2. Why do we return it twice? Why do we have two 2's? So another way is writing something like this. Half 3, we don't need the return type, right? We don't need to return anything because half of number is already stored in the original x. So what we can call is we don't need to define a new variable by calling this function, right? And we can delete this line. As you can see, number is half, right? Initially it's 4. When we call this function, it will take a reference, x, and the number referring to the same variable. When we divide x, we are actually dividing number, right? Now the number becomes 2 in here. And we don't need this one. We don't need the return values of x. So there are multiple ways, right? Especially when you are trying to modify a factor and return a factor. It will be time consuming if you return a vector. So what we can do is we can put a vector into a reference and you can modify it, and then it will be reflected in your main function. So that's the key idea of reference. Any questions on it? No? Well, so yeah, maybe it's better to show you another example in here. Let me change it. Yes. I think. Yeah, it's done. Right, the same files, right? How can we debug? You can debug something like this. You can make it run, input some number, 1. Yeah, it needs to print. Let me remove this one. 2, 3, 0. Right. So when we get into this computer highest, right, we are getting a constant vector S. This one is just a reference to the initial salaries. So as you can see here, we have S, right? And we say this is the call stack main function. Main function will call computer highest in here. It will pass the salaries to computer highest. So what is salaries? As we can see, it contains 3 items, right? 1, 2, 3, and it will be passed to these computer highest function. So this is the local variables for the main function. It has salaries. When we jump to computer highest, it has the S, right? This is the S. It's just a reference to the initial salaries. So it has exactly the same values. They're actually pointing to the same variable called salaries, right? Whenever you modify the S, salaries will be modified. But here we set it to be constant, so you cannot change anything inside of this function. And here is how you can put a breakpoint right inside of the functions so that you can debug and see how it works. When you get back, try to utilize these functions, right? Put some breakpoints and see how it can jump into a function and how it can execute. All right, so we said we use reference because we want our program to be more efficient. Right? We don't want to copy billions or millions of data from main function to the function we call, and maybe this function will call another function. We don't want to copy that. So we use reference, and passing by constant, right? Constant reference will improve the performance, and also we don't want the function to change it, right? We have 2 purposes. But sometimes you want the function to change it, then you don't use constant. If you don't want the function to modify your data, use constant. It's always good when you are passing by constant references, especially for large objects. If you say passing by integers, right, like this one, it's actually not good. Passing by integers. Passing by reference for integers is not good, right? You don't need it. It will consume people, confuse people, and also it doesn't improve the performance. If just the integers, let it be copied by values, it's fine. And also double, integer, and any simple data, you can pass by values. But for complex ones, like vectors, you don't know the size, right? If it's too large, it's better to use the constant references. So have they used this one rule? Whenever you write a function that requires a parameters, always think about a constant reference. How about return values, right? How about return a factor? We can also do that. We can return this one. For example, this one is we need to implement a function that returns a vector. We only need the values, maybe in the range of low and high, right? So your input is a vector b, and also the low bound and the high bound. You want to output a vector that contains all the elements in V that's within this range of low and high. Here's what we can do, right? The naive way, we can define an empty vector, like the result, and we can iterate through all the elements of VI. Right? As long as VI in the range of low and high, we push them back into the result. And finally, we can return this result, right? This is the very naive way to do it. What can be improved? What can be improved? Yeah, change it to constant reference, right? We never modify V in our program. We can use constant reference for here. And another way is, pardon? Yeah, we can move that, but there's another way, right? So let's have the first property here. The problem is when you define it here, right? You're defining a vector. And when someone calls this function, they will assign it from this result to the return value that you want. So there will be another return. Let me see if I have something that's using it. So let me copy it. Right. Initially, we have this function, right? It takes a vector b, returns a vector. So how can you use it in your main function? In your main function, it should be something like this. You can define a function, define a vector. For example, it accepts double, and it has some. Let it be salaries, right? And you want another one, vector double, filtered equals between. We can put a salaries between 100 to 1000. We need more code to see into salaries. Anyway, I just skipped here. So assuming you have some salaries vector and then you put more data into salaries, then you want to call this function. Right? How to call this function? You give it the salaries, right? Initial salaries, you want it to compute, and you get the low bound and the high bound. Right? Here is how you can call this function. Right, we said we can make it to be constant reference, right? It can improve the performance because the salaries don't need to copy all the values. They just give a new name called V, and they will do something. And we say another copy is in here, right? Because the between returns a vector, and this between will assign the return value to another vector called filter, right? So it has another copy actually. What do we? Let me see. What's the correct code? What's the code? Right. It has some copies such as the from here result to to this filter, it has another copy. And indeed, this is in the older days, this would be very bad because you are copying from another vector to this filtered vector, right? Another copy. But nowadays, the compilers are smart enough. When you write some code like this, it will make it just actually a move or a rename to it. So it's fine in nowadays compiler, but in older days it will be some copies. And sometimes whenever this one is used, what are their rules to identify this kind of types? I don't remember, but there's another way, right? There's another way to do it is you can avoid copying. How can we do it? We can put a return vector here, a vector of double, right? You can call it filter, something like that. So in here, you don't need all of them. Oh, wait, you need to define this variable, right? Then what you can do is you can put filter here. Yeah, I need to make it a reference. What else? I need to remove this one. So you can put into the filter, right? You don't need to return. Yeah, something like that. So instead of returning the vectors, you can make your return value become a parameters for your functions, right? This filter becomes your parameters, but it's also the return value actually you want to get. So you can put it here. Notice that we don't put a constant here, right? If it's a return value, we don't put a constant here because we want to modify. We want to store the result in filter. So we will keep pushing back into filter. And after doing the work, all the result will be in filter. So they are different from with the previous implementations. And it can be extended, right? What can you do next? For example, you can define remainings, right? How about I want to return two values, right? Remember you guys asked me questions. How can a function return two vectors or two numbers? What we can do is put all of them into the parameters and then using reference for it remainings, right? And use another line. That way. I need to modify here as well. Right, in your function call, not only the filters is the return value, you also want the remainings to be the return value. For example, if it's outside of the range, right, outside of the range, you can push it into the remainings. Then in this way, you can return filter, you can return remainings, right? There are multiple ways to get the values. So any questions on this? Yes. Oh yeah, that's one comment. Sorry. Yeah, if we want it to be complete, there should be else part. Right, else remaining start push back B of I. You don't need to return anything, right? Notice that this one return type is void. But actually, you are keeping all your return data in these two vectors because they are reference. As long as you change in here filter, it will change in this filter, and you can use this filter after calling this between functions. Yes, question. I didn't hear the first one. Okay. The name. So how about we have the name? So name doesn't matter, right? In here, we can call it R. Here we can call it F. And we can call them using this way, right? Name doesn't matter. We define two vectors, and these two vectors will be, this F will have the same name as filters. They represent the same vector. R and the remainings will represent the same vectors. Name doesn't matter. These are just the parameter names. Here are the parameter names. They are local to this between function. And this F and R are the variable in main function. And you can use them in this way. And after here, we can continue do something with F and R, right? B, no, and R, yeah. I just skip the remaining code. So, any more questions? No? All right. So come back. Again, in C++, because we care about the performance, right? We want to reduce the number of times you need to copy data, especially for vectors and many large objects. In the future, you will define your own classes, and inside one class may define multiple data. At that time, if you want to copy, you need to think about another way. Can I avoid a copy, right? And return numbers, because we introduced the reference, return values can be inside of the parameters, right? Every parameter can be a return type. As long as you put a and sign here, it can be changed in the main function, and they will see the difference. Here is another example, right? How we can write a function that collects the positions of our values that are in the range of low and high. Right? We can write something on your own. So basically, in the previous one, we are storing the data, right? Now we are storing the index. That's the only difference. You can try that. Here's the solution, right? Now we are storing the index. It's quite straightforward. Next one, how can we write a function that checks whether two vectors are equal? Equal means they have the same number of elements and they have to in the same order. Right? Every corresponding element should be exactly the same. That we mean by two vectors are equal. As you can see, we define, because this equal function just check the values, right? We don't want to modify the values in A or in B, so we just keep them constant reference so that we can avoid copying the data. And also we want it to be without modifying the data. And it will return a true if they are equal, return a false if they are not equal. All right, so any more questions on it? No? All right, reference part is a little bit hard to understand maybe. And now we will get into the easy part, right? Understanding some of the functions that arrays will perform. So first one is how can you remove an element inside an array? For instance, you want to, if I give you the vector v, you want to remove the positions. For example, if I give you an I, you want to remove this element. How can you do that? So if the order doesn't matter, right? If the order doesn't matter, we can copy the data here and pop back the last one. Here is the implementation, right? We should first get the last position, like the v size -1, and we can copy the data from the last position to the position you want to remove. You override the values, and you pop back means you delete the last one, and also you are doing one extra work is modifying the size of the vector. Remember, the v dot size is very important, right? V dot size. When we are doing iterations, we will use that. So these are the implementations, and indeed, they have already implemented all these functions. One is called, let me see if there's erase. Yeah, there's an erase. This is the erase function they have provided. Push back. Yeah, it requires some of the iterators, which will be discussed later. All right, let me come back. So this is the basic ideas. If you want to erase one of the elements, you just move the last element to it and then pop it. Any questions on this? The reason we pop is because we want to change the size of v, right? If we only modify it like this, v's size doesn't change. So v still has the original size. If the original is 10, you remove one, the size is still 10. But if you say pop back, it will minus the size by 1. You cannot directly modify the v dot size. It's a constant number. How about we want to maintain the order, right? If the order matters, if you want to remove one of the elements, what can we do? We just iterate from i's position and copy the next position to I plus 1 to I plus 2 to I plus 1, I plus 3 to I plus 2, and override one by one, and then pop the last one, right? So let me show you the example. Let me see if I have time for that. Do I have one? No. All right, never mind. So any questions on it? Exercise, right? Assuming order doesn't matter, how can you remove all the elements in the range between low to high? If I have for example, this is salary, right? You want to remove all the people salary, for example, too large, then how can I do it? Modularize, think about modularize, right? First, you need to define a function that can erase one item. Then you can implement this function. Let me see if I can do it. Four. right? Assuming I have a vector, it contains 4 elements, 1, 100, 2, and 200. And I want to erase all the elements between 90 to 300. So the remaining should be 1 and 2, right? So how can we implement this function? So modularize it, right? How can we modularize it? If we want to erase in the range between low and high, what we want is, okay, if I can implement a function that can erase just one position, right? Ith position, then it might be good. Then how can we, if I already have a function that will erase, and maybe we should use another name, position, right? If we know the position I, and I have already defined a function that can remove the ith position of inside of V, right? If I already have this function, considering that way, then how can we do it? It will be exactly the same as the original one, right? The one we have shown in the master slide. I less than V dot size plus I. But what we can do is if V of I in the range of low and high, so it could be greater than low, and V of I less than equal to high, we can erase the position, right? Assuming we have already implemented this function, then we are done.
After you erase both V and I, you need to minus the Y.
Yes. Yes, that's correct. Because we have changed the size of V, right? That's good. See the problem? Yes. Good. So the V dot size, whenever we set it here, it's already predefined, right? And it will be replaced by some number. All right. So we need to think about another way. So if we can define a function that void erase position of this function, comma int position, right? In this one, what we can do is we can copy the code. Where is the code? Assuming we care about the order, we copy the code here. Right, we are doing something like this. Because after this erase a specific position, yeah, this should be, yeah, correct. The size of V is changed. So here we need to do something different, right? What we can do is, whenever we erase it, we can VI minus minus. Yeah, we can do that, but let's make it more clear. Right, something like this. But remember, all right, I'm making it too complex. I'm talking about modularization, but we care about what's the behavior of another function, right? Because this function modifies the size, and we are still using v dot size, then it will be a problem. Let's see what's the problem here. Okay. Let's first try to see the problems. And while you are debugging, it's quite likely you will see this kind of problems. Use it. Namespace. Yeah. Any more errors? I believe no. Yeah. So let's try. This one is test 4. And I believe it will have some of the, no errors. Yeah. Let me see. Anyway, let's print out it. Let me put it down. Right, so let's make this one very simple, right? All right, so we define a vector, then we want to erase anything between 90 to 300, right? We are expecting this one to output 1 and 2, right? So while we are calling this function, we erase v 90 to 300. So we are passing v to here, another v. Although they are the same name, the name doesn't matter, right? Let me emphasize it again. V can be v1, right? Can be any name, Name doesn't matter. Now v1 points to the v1 points to exactly the same vector as v. Right? When we call erase position vi, position v1 and I, v1 will and v have the same name. So there are 3 names, v, v1, and v. Actually, they are pointing to the same vector, right? Same vector here. And whenever we have a test range, we do erase the position. So here is the modularization thinking, right? You want to implement erase. How about we implement a function called erase a specific position first? If we already have this function, we can simply define something like this. If it's in the range, we erase this one. And how can we implement erase a specific function? It will be much simpler question than the original question, right? The original question is erase all the elements inside of this range. It will be too complex. Make it simple. Erase just the one position. Erase just the one position. And using this function to implement your complex functions, right? Thinking step by step. So any questions? Yes. Change 2 to change 2 to 50 to this one, 100 and 50. It doesn't matter actually. They are in the same range, right? You mean this one? Yeah, it might be. Yeah, it might be problems. Yes, because of the last position we did. Let me see. All right, let's see how to debug it. Debugging. Let me see, where is it? Test 4, right? Actually, the one that's most likely to be wrong is in here, right? Is in the erase function. If we assume this function is correct, then most likely the problem will come from here. So let's do the breakpoints and step into it. All right. When we first step into it, we have the V1. Right? What is V1? 1, 100, 150, and 200. Right. And for now, this I, where's the I? Where's the I? I equal to 0. And we can see if Vi is greater than low, 1 is not greater than low, and so this one will go to else part. Else part means do nothing, right? We will go to next round. So next round, I becomes 1, and the V1I becomes 100. 100 is greater than low, low is 90. So it will get into here. It will erase this one. So how about, let's see what will happen when we erase the position 1, right? It becomes 3 items, 1, 150, and 200. The 100 is already erased. And now this I becomes 1. Next, I becomes 2, right? See the problem? This I becomes 2 because we didn't ask I to step back to see the original values of the current items. Each time it will increase the I automatically, right? When you are, yeah, just add I minus 1 here, minus I here, then it will testing this element again because the original 1 was already being erased. Now we need to test the 150 again. So that's the that's how we can do it, and how we can debug. Right? See the problem? The problem is because the index I, right? Whenever you erase something, it will directly jump to the next one. Yeah. But this next one, yeah, maybe it's a previous. You can walk into it step by step, and to see what's the problem, and you can fix your code like this. All right. So debugging is very important. And the reverse side, right, when we are trying to insert one element into a vector, you can insert it into, you first copy, right, from the last position, copy everything from the previous position, and this I position will be duplicate of I plus 1. Then you can put your new data here, put your new data into position I. Let's see how it works by looking at that code. Where's the VS Code? Let's see what can go wrong. All right, let me insert insert V. First one is the position maybe 1, and wait, it's a string. Let me see, it's a string, yeah. Make it double. Make it double. Right. 5. Let's insert 5 to it. And then let me break in here. All right, debug it. We will directly jump into here. We skipped all the functions in the main, and you can see V now contains 1, 100, 150, and 200. When we want to insert a new number into the position 1, we need to copy everything after it, right? Let's look at how we can do it. We first push back this last. So it will becomes 1, 100, 150, 200, and 200. Right? We make 2 copies. But at least for now, we have increased the size by 1. And then from the last position to the current position, we can copy it, right? Doing once. 150 will be copied to the index 3. Once more. Wait. 100 are copied twice, right? And each time we are copying from the previous item to the next item. And then it will jump out of the loop and assign this position. Wait, is it working? Not working? What's wrong with that? Let me jump out. I don't know what's wrong. Wait. Okay. I believe it's that. But anyway, this line will do assigning your new S to this position. Well, yes. All right. Yeah. I believe it's because of the network. I'm connecting to my server, and if the network is not good, it will lag. All right, so that's the key idea, right? You can put this code in your IDEs and do it, debugging it step by step, and to see what's the behavior of it. So this is the insert one element. The key idea is using pushback to increase the size. Okay? Using pushback to increase the size of V, and then you can copy data one by one to the next item. So how about write a function that removes duplicates from a vector? If you want to think of from modularizing way, how can you define it? You can define a function, right? That's called remove duplicate. And you also need another function called maybe erase one specific position. If there's any duplicate, you can remove that position, right? Think of from modularization ways, defining maybe 2 to 3 functions to do the work. How about implement a bubble sort of double array? So what is bubble sort? Bubble sort is like this, very similar to that one. So if you have a, yeah, it's closed, maybe the network issues. All right, so assuming you have numbers like 1, 3, and 2, right? Bubble sorting means comparing the neighbors 1 and 3. If 1 and 3, if 1 is less than 3, it's okay. If not, we will swap these values. So let's look at the next one. How about comparing 3 and 2? Right, swap. We can swap it. And then we're doing it again from the beginning. Comparing 1 with 2, it's done. 2 and 3, it's done. Then it's sorted. So sort means, right, making this one in an ascending order or descending order, right? This one using ascending order. So bubble sorting, if you want to implement a bubble sorting, what are the functions you need to implement? Yeah, swap. You need to implement some function called swap. For functions 1, swap values from 2 positions. Like you need something like the, let me see if I can copy something. Let me erase this one. Int position, int position. Right. Let's call it swap. So modularize it, you can implement the first function that can swap 2 indexes inside an array, right? If you will be able to do that, then bubble sorting will be very easy. You compare 1 with neighbor. If it's less, it's done. If it's greater than the neighbor, swap it. If it's greater than neighbor, swap it. So that will be a very simple example. You can implement by yourself. Right. I want to quickly cover 2-dimensional arrays because you will use it in your homework. Here is how we can define a 2-dimensional arrays. And actually, I forgot a blank space here in after this type. All right. So vectors, we said vectors, every element of a vector can have some type. Right? Here we have integers. of n vectors. And then this one, we first define a vector, right? Its type is vector of int.
Yeah.
So it has 1, 2, 3, 4, 4 elements. Each one is a vector, right? Vector 1, vector 2, vector 3, vector 4. These 4 vectors are the CT, it's the elements, and inside each one is a vector, right? One thing we didn't specify is what's the type, right? The first type could be 3, second type could be 4, next type could be 6, next type could be 10. We didn't say they have to have the same size, right? That's the two-dimensional vectors. And if you want to represent it, it's like something like this one. So any questions? Two-dimensional arrays, right? You can define your painting board like this way. So here is how we can initialize it. Right? We can initialize a vector with n of them. Here we have 4. This n means 4. And for each one, it's a vector of integers, and each one have m numbers. So here m equals to 3, n equals to 4, right? Here's 4, here's 3. And if we want to initialize everything to be 0, we can say each element of the VBC is a vector of m zeros. Like here is what we can do. So one key difference between two-dimensional arrays using vector and the two-dimensional arrays using the older series is this one can be a variable. Right? N can be a variable. But if we have time to cover arrays, we know this size should be known by the compiler for the C styles of arrays. So that's the difference. Right. How can we index each element in a two-dimensional arrays? Right. We know this is the way we can access the element inside a normal vectors. How about two-dimensional arrays? Similarly, let's see if we have one. Yeah, this one, right? So let's first introduce another one. It's called iterator through containers. But don't be scared about the names. It's just a better way to access the element inside a vector. So typically we say vector like this, 3 elements. So we say I equal to 0, I less than 3, plus I, and vi, right? Another way to access it is we put a v here, comma here, and we set the type is double. This is the element of this v, and we can see out elements 1 by 1. It's actually output 8.1, 9.2, 1.0. So this is the simple way, right, to iterate through these vectors. And similarly, we can do something like this. If we have two-dimensional arrays, vector of double, right, two-dimensional vectors, we can access the first vector, right, or the first dimension of v, put them into element. Indeed, each element is again another vector of double, right? The v is vector of double. So each element of v is vector of double. So you can see out, you can, wait a minute. Maybe I forget about, yeah, maybe I forget about another loop to access each one of them. Yes.
Element, keyword, or variable?
Element is a variable you have defined. So I will show you this example. Let me use this one as an example. Let's see if I can connect it to that. Yeah, network is back. So in here, right, we can define our two-dimensional arrays. And we can use a for loop, right? We can define a new variable called this. This is the type. This is the variable name. And we can do something like this. And we can have another for loop, right? We can int, let the name be A, let the name be E. I just want to show you that the name doesn't matter. But for you, you need to give it some good names. Cout A, in order to show it correctly, we can put some new lines in here, right? You can show the result. Connect it to it again. Right, here is how we can access it. So this one is exactly the same as for loop using index. For loop, yeah, using int int I. We hide it. Right, exactly the same. We can use index I and index j to represent the first dimension and then the second dimension. Right? The first dimension is BCT.size. Its size is 4. And BCT0, which is the first 1, 2, 3, its size is 3. So j will iterate from 0, 1, 2. I will from 0, 1, 2, 3, right? And you can output BC row, J's column. This is how we can access the element inside a two-dimensional arrays. So here is just another way, right? If you just want to iterate through these factors, you can also do something like this. It is nice and clean, but for now, you can use the index way. It will help you understand what is the index. And this next line, this E and this A are just some numbers. You can also put some reference here, right? You can put some constant here. It doesn't matter. They are just some types, definitions. Any questions on using I and J? I and J to index these two-dimensional arrays?
We can look for the under coordinate A, colon E, that's in not a vector.
Yeah, this A is again a variable, right? The E is actually a vector. E is a vector. But E's element is int, like the vector BCT. BCT is a vector of vector. Its element is a vector of int. Right? This is the type for E, which is each element of BCT. This int is the element of E. Right? It's another one. So here, this E is a vector of int. right? So each element is an integer. You can access it like this way. Yes.
So if size of each vector is not the same, so
Yeah.
just
We need to change.
0 to I.
Yes, we need to change VC0 to VCI. Correct? That's actually a better way, right? In this case, you don't need to care about whether these sizes are the same or different. If we change a little bit, 0, 1, right? If it's not a n by n, but something that's not regular, it can still output working correctly. If we put an I in here, right? Any questions? We only defined BCD is a vector of vectors, right? We didn't say each vector needs to be the same size, so it can be different. We can use this way to get access to the size. Let me erase these two lines first. Here is where you should write I and J, I column, I the row, and J's column. Questions? No? All right. So yeah, I have already implemented a function that can print a matrix, right? Matrix. How about a function that computes the product of two matrices? If you have a function that is 4 by 3, right? That's 1, 1, 2. This is a 1, right? You can have 2. It can be by 3, so you don't need it. You want to compute the product of two matrices. I believe you guys have already learned in algebra, right? No? All right, never mind. So you can skip that. So factor of matrix multiplication is just 1 times 1 plus 2 times 4 plus 3 times 10 becomes one element. 1 times 2 plus 2 times 5 plus 3 times 11 plus another element, and so on. Yeah, let's skip this one because you haven't learned in linear algebra yet. It doesn't matter. Yeah, so I have already covered almost everything you needed for your homework, right? Two-dimensional arrays, references, how to modularize our functions, and so on. And the arrays, I said I will introduce it in next lecture is because other people will write in the old array ways, right? You have to understand it. But for most of you, just using vectors, it will be more stable and less bugs. Any questions? No? All right, let's stop here and you guys can ask me any questions. Just to come here. Okay? Yeah.
We're having office hour today.
Yeah, I have one. It's in, let me see.
2 to 3, right?
Yeah, actually, I opened the 2 office hours.
Oh.
Thursdays to 3, Tuesdays 3 to 4.
And then is there going to be a lab tomorrow for the Friday class?
Oh yeah. By the way, for Friday's lab sections, because tomorrow is Mid-Autumn Day, right? So we will have a makeup for that. Because Friday's lab sessions will be canceled twice, right? So we will have one extra makeup lab sessions for that. It will be October 16th. I will put an announcement on that. It will be far later. Don't worry about that.
Thank you.
啊，那这个是怎么实现数据输出的？就是不用那个 for，
不用 for，对，这个不就是一个 for 吗？对吧？这就是一个 for，
不用那个2个索引。
对对对，
它是就自动检索所有的
自动检
这个类型
索所有的
的
element。
上面这个和我把它 vector int 改成 int 有什么区别？
不行啊，它的首先 VECT 的每一个数据的类型是 factor of int，它的数据类型不是一个 int。
这个 vector 的，就是我二维向量的定义方式和二维数组是不一样的。
对，
它这个是一个套娃的。
对对，它这个套娃1套1套1套1层。
所以说我由此我可以套 n 维数组，
无穷多维你都可以套。
哦，所以说这有点不一样，跟那个普通的 array。
是的，是的。
这个是什么意思？
就是它去循环所有的 element 在那个 VECT 里面的所有的 element， 这个
是相当于这3条数组。
对，就它首先是得到第一个 factor of int， 然后得到第2个 factor of int， 然后得到第3个 factor of int。
那它是拿到1、2、3这3个数据吗？还是说
直接把数据拿到？对，直接把数据拿到。所以第一轮你可以 debug 一下。第一轮的 e 就等于1、2、3，第2轮的 e 就等于4、5、6，第3轮的 e 就等于7、8、9，
就是便利数组的。
对，它就是便利它每一个元素，
就相当于那个 i 小于0，然后 i 等于0 ，i 小于0。
对，它有个隐藏的东西在里面，它帮你实现了，让你看起来代码更简洁一点。
然后这个也就是便利 e 帮1、2、3
对对对，所有的一个
含水的那个 library。
所以它就省掉了 index 那个。
是的。其实它叫 iterator， 其实不太一样，就是以后会学到，后面会里面。
杠七，
杠七
tab， 这是个 tab，
就这个 tab 键。
那我这个杠 G 可以直接写在这个 a 后面吗？
不行。你是说它只能一个变量一个变量的输出，这是一个变量。
杠 G 它是
一
个字符串，
对，它是一个字符串，是的。
但是如果我是说我输出的值本身就是一个字符串，那我就可以直接把它加在里面。
也不行，你要写个加号才能把2个字符串加在一起。
不是，就是说如果我这里的类型就是字符串，
你也要用个加号把它加在一起。
也要吗？
所以可以字符串加变量吗？
字符串加变量可以，
但是我看我们
的变量
之前输出 hello world 的时候，那个反杠 n 是直接跟在那个。
对，如果是一个字符串的 literal， 也就是说是 a b c d e f g 那种，而不是一个变量的字符串。如果是一个变量的字符串，那你还是要这样的输出。
我说的是
如果是那种是可以直接加到后面。
所以可以 hello 杠 n。
对，可以。
我是看这个。
这个就是如果 int 就是这个数组类型给换成 string 的话，那是不是后面这些都
换成 string？ 对的，没错。
那就我也有一个问题，老师，你 PPT 打开一下21页，有那个
21。这里，对，这个，这是个 return type， 你一个函数 find all between， 这是一个函数。
这个意思是它函数的
return
返回值是一个
返回
元素类变量那个什么
返回的变量类型叫做
元素类型为 int 的。
对，一个向量。对，
我当时在想这个地方不会报错。
这是个 type， 你就把它想象成一个 type 就行了。它是一个对，它是一个变量类型，它是一个 type，
是一个长得比较奇怪的。
对。
之前有一个 S 赛说的是那个 random 和 S rand， 那它这个 S rand 是不是要有一个种子词？如果我把种子词设置成 time 的话，它会递增，那它就看起来不是很随机。
所有的随机在电脑里面都是假随机，都是要从一个种子开始的。真的随机是只有在比如说量子物理或者物理世界里才有的。假的随机干嘛用呢？就是让你每次调试的时候可以得到相同的问题。比如说你有一次用一个随机种子得到一个错误，你想重现一遍，你就用相同的种子去给它，你就能够重现一遍你的错误。不然你每一次都不一样，你有可能在这种情况下是对的，在另一种情况下是错的。对。
这块的话，就是它需要写这个返回值吗？
需要啊。
也需要返回这个类型的
因为它
是吧
不是一个 void 的函数。
因为它你要不就写个 void，要不说它不返回任何东西，要不就说它返回一个 type，它的 type 就是 factor of int。
但是如果写 y 的，然后括号里面是引用的话，
可以
就已经自己就会
对，
变
它会变，对，它会变，就不需要一个返回值。
那如果我写一个这种函数不 return 会怎么样？
这种函数不 return 嘛，它
会报错
编译器会报错。
哦，
对，编译器直接就告诉你这是错的。
compile run 呢？
对对。
我在想我的 compile run 是哪个？